Hello everybody, this is Mike Kretovic presenting my STEAM unit teaching experience. I hope you've liked what I put together, and let's get started. So to begin, just some background on myself and the school. This is going to be an AP Physics class, so we have 12th grade students. The school where I teach is a STEM-focused charter school. So our student body is not a typical representation. We have a much higher focus on mathematics and science. So the students at our school have a very strong foundation in experimental methodology. All of the science classes have lab requirements. So by the time they get to 12th grade, we're dealing with students who are very familiar with how to set up and design their own experiments. They also require calculus and physics before they're allowed to do AP Physics. So we will be using that as part of the lesson design. I had 2 classes this past semester, or this current semester, this past lesson, of 8 and 6 students. So this is a smaller classroom size. Just a bright bunch of kids. So the scenario that I put together is I have a stranded group of survivors. The students are taking the role of U.S. Coast Guard search and rescue. They've just received word that a ship has sunk in the Florida Keys, and they are responsible for providing aid to the survivors on a desert island. I'm going to be breaking the students up into small groups so that they can coordinate their plans. There's a couple of complications for this. There's an inbound hurricane to the island. Due to rough waters, they're not going to be able to send a boat, and there's no place to land a helicopter or plane, as well as no means of direct communication with the survivors, so they won't know their exact condition. So the mission plan that I give to the students, they need to assemble an airdrop package to be delivered to the survivors. The package should contain the tools and resources needed to give them the best chance of survival. And they need to design a delivery system so that it can be dropped safely from an aircraft to the island without damaging the supplies. This entire plan is really just an elaborated version of the pretty typical egg drop science lab, where you have to drop an egg from some height without it breaking by designing some sort of parachute or cushioning system. And I really just wanted to take that core idea and expand it out into something a bit more transdisciplinary by incorporating some real-world elements and creating a much more authentic experience. So a couple additional details if you want to try implementing this. The survivors will have a 6-hour time window after the package drop before the storm hits, so if they need to do any shelter building or first aid on site, that's kind of their time window. I told the students that they should assume the storm is going to last around 12 hours to give them an idea how long these people are going to be required to survive for. The initial plan was that the survivors don't have any knowledge of first aid or shelter building, that the students would have to provide some sort of instructions. And I wanted to make sure budget was not a factor, so they can put together whatever crazy contraptions or technology that they want. All right, so the expectations from this was that they were going to be designing their own survival strategy, the list of supplies along with weights so that they can figure out the mass of their delivered package, and as well as designing the delivery strategy. And that third part really was the biggest focus for the design elements. I wanted them to create their own parachute or small-scale modeling. They will then need to do their small-scale testing and build some mathematical models to show that they will be able to calculate how the object is going to fall. So this involves two-dimensional projectile motion, and the bigger part of this unit is focusing on air resistance. Since this is an AP class, they have the mathematical background in order to succeed at calculating the motion in 2 dimensions. And that's going to be built based on their small-scale testing to figure out, okay, how big a parachute do you need? How heavy can the delivered package be? And then at the end, students are going to need to put together a presentation of their mission pitch as if this was an actual Coast Guard meeting to explain why their plan is the best strategy for ensuring the safe recovery of the stranded boating victims. The driving questions for this are Newtonian mechanics and aerodynamics to minimize forces on a falling object, being able to predict the location of a projectile in 2 dimensions with air resistance. And then to make it a little bit more transdisciplinary, it's what survival strategies can be used in an emergency situation. Now, of course, that was the initial plan, and 2020 has been kind of rough on plans. So while I initially had assumed that we'd be having classes in person 3 times a week, and would have a lot of direct interaction between me and the students to help them with their small-scale modeling and designing the lab components, all of which had to get thrown out because things changed. So the biggest change that we had was our school shifted to a hybrid method with 1 day in class, 1 day remote, and alternating a 3rd day between the 2 sets of classes. So 2 days, 2 remote classes 1 week, and then 1 remote class the next week for each of the 2 classes. So with that in mind, I had to do some adjustments to the overall plan, but I think I was able to pull it off pretty successfully. So the new plan, the overall scenario remains the same. Instead of having each group build 1 model, each student was responsible for designing their own model at home using recyclable materials. And then in class, the group would pick one of those to use as their actual testing going forward. I did that so that students would have more time to work on building their models when they were at home, rather than using up the very limited in-class time we had that needed to be focused on actually getting data for testing. I also had to remove the survival portion, which I really didn't want to, but I needed to keep the focus on the physics, given that we had a much more limited time to work with students. So instead, I gave them a fixed weight for their package with a few dimensions, which I guess would be the equivalent of just giving them their own egg rather than designing something as their delivery. Focus remains on the mathematical modeling of the object, and the students still had to display an understanding of 2-dimensional motion and variable air resistance. I also changed the presentation method because I wasn't sure if we were going to be able to reliably put together entire class to sit and focus on listening to each of the groups do their pitch. I still wanted them to record some sort of presentation, but they could deliver that to me via email rather than it being in front of the class. So the in-class days was focused on testing. They needed to be able to use measurements of their falling small-scale models in order to build up the aerodynamic parameters of it. And this was also my biggest opportunity for me to step in and see how students are doing, provide a little nudges where needed. For the remote days, the lessons were focused on the actual mathematics, the physics tutorial, assigning homework, going over that foundational element, as well as reviewing homeworks and helping students through the mathematics. So overall, I think things went pretty well. On the positive side, the students were actually really successful at working cooperatively despite the hybrid setup. There wasn't really any in-group fighting. There was a lot of clear coordination and assignment of who was going to be doing what. The students really understood the mathematics of 1D air resistance and how to calculate that experimentally and mathematically. We had a lot of good designs. All of the packages were able to be delivered successfully, and the students really had a good time with this. I think part of that may just be that with this new schooling environment, having some sort of hands-on project was just really what they needed, but definitely a lot of positive feedback. From the negative side, there was a bit of a difficulty on the experimental element. I think that may have just been due to the equipment we had not being ideal for taking precise measurements of falling objects. The other part may just be that with the small-scale modeling, air resistance was such a small factor that it was essentially equivalent, at least for some of them, to falling without air resistance, because that really only becomes a factor when you're dealing with very large objects or high speeds. Some of the students had difficulty building their small-scale models, but I didn't hold that against them too much, just because it was an unexpected obstacle. The equations for 2D motion with air resistance are a lot more complicated, and the students definitely seem to struggle with that element more. It's not that it's mathematically too much more difficult, it's just the equation has like 15 different terms in it, And so it's very easy to lose track of rounding error or something. I think if we had more time to focus on that, I could have ironed it out better. And that kind of gets into the next point, that if I hadn't been alternating the instructional lessons and in-class testing lab components, I think it would have been a lot clearer. But jumping back and forth between remote and in-class definitely muddled the waters. And as a last note, I should have been clear on what my expectations were for the group presentations, because those were kind of all over the map. All right, so looking for the future, definitely number one, want to eliminate the global pandemic. I would not recommend trying to implement this lesson during a once-in-a-century global catastrophe. I'd like to reintroduce the survival elements in the future just to bring in that transdisciplinary component. I think it also would have helped the students have a bit more engagement with the lesson directly if they got to design how they wanted to build a shelter and think about what supplies needed to go into it. Excuse me. Definitely not alternating lesson and lab days. Even if I have to stick to doing this again with a remote hybrid lesson, I think I'll just, even though it's not maybe the most efficient use of time, having just the first set of days, both remote and in class, being lesson focused, make sure that the foundation is there for air resistance, and then moving on to the lab component and actually building things. For the small-scale materials, I think providing stuff from the school, at least a core set of things like parachute materials, adhesives, just so that everybody has a good foundation that they can add on to would be helpful. Having more time for testing so that we can get good measurements. We had one group of 4 people in one of the classes that was a little bit unbalanced, and I think 3 really is the maximum. When there was 4 people, there was a lot that I saw of students not having anything to do during the testing. And then being more consistent and upfront about what my expectations were for the presentation, even if it's going to be in class or recorded again. So that's pretty much my lesson experience. I think it went pretty well, all things considered. The students had a good time. They learned most of what they were needing to, and with some additional lessons at the end to help solidify the 2D motion, they got all of the core physics elements that I was hoping. I don't really have a strong ending here, so I'm just going to stop talking now. Hope everybody enjoyed it, and I look forward to reading the commentary.